Here we are. Um, I'm looking at Natalie. Can everybody hear me? Fine. Okay, good. I'll go right ahead then because there's a lot of ground to cover. Um, so first off, some of this stuff has already been mentioned, so I'll go through this quickly. But a very simple overview of BGP where everything is fine. We have two different ASNs announcing two different prefixes. The AS 65003 here gets them both and sends them on to another peer. Um, so that's all great. No conflicts here. Well, unfortunately, with bad intent or by whether it's really an intentional hijack or it's because somebody misconfigured something, it's possible for two ASNs to announce the same prefix. Um, and it's a bit in a way, I guess, like any cast, if the prefix has the same length. It depends a lot on local preferences, shortest path, and other metrics. Whether the hijacked path will then get preference or the intended, like the normal one, would win. So part of the world would see the hijack, let's say. More specific announcements always win in BGP. So that attack, if it is indeed an attack or misconfiguration, would always work. So this is a bit of the problem domain. And origin validation is one way to address this. Most commonly, origin validation actually used by providers these days. I'll get into that into a bit more detail in a moment. It's mainly because providers don't want to be seen as aiding and abetting to these kind of things. They have a reputation to protect, etc. Internet exchanges have started offering filtering as a service as well recently, but it's really up to users to decide whether they want to use it. Transit providers usually really do not filter. And stop networks, what I mean by that is people who are not really providing BGP services, let's say, but have content. They may still want to filter based on origin because they want to block certain traffic. It's just one of the things people might do, like if they fear they're under threat of hacks or spam or anything like that. So carrying on. How do you go about this origin validation? So this has been around for a long time, actually, root objects and the equivalent root 6 objects for IPv6. A root object can be created for a prefix called root here in the bottom and a origin ASN, and it needs to be authorized by both the holder of the prefix and the ASN. In the RIPE database, actually, the authorization by the ASN is about to be removed, and only the INetNum holder needs to authorize. The mechanism available in the database is, well, it varies what people use, but you can have a simple password, you can have PGP signing of your updates, or you can use a single sign-on account and update your objects through a web interface. So these root objects live in what is called internet routing registries, and there are many out there in the world. But the most widely used one that I'll go into today are the RIPE database and RIDB. Verification of holdership over resources, well, that varies a bit. So in the RIPE database for the RIPE region resources, that's done pretty well, I'd say. We verify, or there are systems in place that make sure that only the holder of a prefix can create a root object. But for out-of-region resources, for historic regions, it's also possible to create those, and basically anybody can create them. In the RIDB, again, that's about to be deprecated, but I'll get back to that. The RIDB actually allows paying customers to create any object. So, and a lot of other RARs don't formally verify holdership. So there's some question here about the legitimacy of root objects that you might get from various sources. If we look at RPKI, that's a more recent standard being developed in the ITF. This is based on RPKI stands for Resource Public Key Infrastructure. So it's a public key infrastructure system. where we have a certificate where resources are tied to a public key, and the secret private key that corresponds with that is used to sign, in this case, a subsidiary certificate for online systems. So for RIPE NCC, speaking for RIPE NCC, we have an offline system that we keep very safe, and then we have an online system for daily operations. From that certificate, we sign certificates to members, to LARs, with their resources on it, and then they can use their private key to make so-called ROA objects, where a prefix up to a certain length is, well, let me rephrase that, where an ASN is authorized to announce a prefix up to a certain length, and this attestation is done by the holder of the prefix. So the ASN gets to decide whether they want to announce or not, but they don't have to authorize this message, let's say. How does that then pan out in various examples? So here I'm showing BGP again with a ROA object and a root object. In this case, a different ASN is announcing the same prefix as the other one. There's a ROA and a root object that say 10.0.0.0/20 should be originated from AS 65001, and we see it coming from 002. So in this case, actually, both the root object and the ROA would reject this announcement if AS 65003 does indeed filter. Now a slightly different example, more elaborate. Let's say AS 65002 is really evil, and they know how to spoof the AS 65001 and pretend that they're further downstream from them. So what they might then do is announce more specific, prepend the path with AS 65001, and generally speaking, this would work if people don't filter. Now, the ROA, if you that I've used here, actually doesn't allow the more specific announcement, so that ROA would reject this this particular hijack. The root object may not. We've asked some people in the past, and for root objects it varies a bit whether people will or will not accept more specific. But yeah, so your mileage may vary there. So carrying on, let's talk about how do people use this information actually. So for root objects coming from an IR, typically people use tools like the IR toolset, BGP-Q3, or their own scripts to query or fetch objects from various IR databases. And they do the processing, and then that results in static router config. Typically, I believe this is done by providers for their own customers. People don't typically do this for all the announcements that may exist in BGP, because it would result in huge filter lists, like to, what is it, like 600, 700,000 these days. So I think that in itself, that the config is static, is one of the reasons why traditionally origin validation is really only feasible close to the source, let's say. But if we look at RPKI, then that may become different. At least it's the intent in the RPKI standards to allow this to be different. Now, in its RPKI publishes objects in a repository that's available over rsync, or there's a new Delta protocol using HTTPS, but I won't bore you with all those details. What's important here, you need to run a separate tool, an RPKI validator, and there's a few available in the world, all open source. Ripster is one, Arsenic is another one. The RIPE NCC has a validator that's available on our website, and we're actually about to do a beta launch and a production launch of our next release of it. In any case, you run one of these tools and they all have APIs, so you could use that and then feed that into scripts you have set up locally, and then generate static router config. But another way to do this is to use the so-called RPKI to router protocol. So that way the router gets information from your validator directly. And that allows you to essentially have pretty simple config in your router. Most, well, I'm not sure most, but many of the router vendors support this these days. And it allows you to do things like if a origin is valid, then set some local preference. If it's not found, meaning it's not covered at all, have some somewhat lower preference. Or if it's invalid, drop it altogether. That's actually the recommendation coming out of the IETF to treat it this way, because if you wouldn't drop invalids, then more specific invalid announcements would still win. And a takeaway here, I think at least, is that because this config is relatively simple and it works with a static table in your router, and it's very, well, it's pretty low cost, CPU-wise, let's say, this enables validation of the full table, not just for your own customers, so also further down the line, let's say. Now, if we compare the two objects, then, well, for a large part, they're doing the same thing. So they're authorizing prefixes for an ASN. But the authorization models are quite different, of course. Now, for root objects, it varies. It may be pretty good, or quite good, but it may also be weak, or it may be absent even. This verification of whether the statement has been made by the real holder of the resource. With ROAs, that's much more formalized and strong. The validation side of it is also different, of course. With root objects, well, you essentially get them plain text, so you have to trust that nothing changed in transit. With ROAs, you have object security, and you can do validation locally. More specifics, like I said, if a more specific announcement is seen, then for root objects, it's kind of undetermined what the outcome is. People treat it in different ways. For ROAs, that is very explicit in the standard. So more specific gets rejected, but, and that's why the unless is here, you can optionally say allow announcements up to a specific length. Propagation, well, typically root objects are downloaded, I think, on a daily cycle. Of course, you can have networks that do it more quickly. For ROAs, well, it depends. I mean, if you look at the propagation between the validation, the publication and the validators that run, that's pretty fast. After that, it depends. If you use the RPKI to router protocol, then it gets into your router quite quickly. But if you use static scripts and you generate them once per day, then obviously it also takes a while. Maturity, well, root objects have been around for a lot longer, obviously, but ROAs have now also been around for almost 7 years, so it's not that new anymore either. So, carrying on. This is all very nice, comparing these aspects, but yeah, to have usable data, you really need to look at other aspects as well, like what is the coverage, how well does it reflect what's going on in BGP, and would you shoot yourself in the foot if you use it. So starting with the RIPE database IR, we see that coverage is mainly the RIPE region, and for historical reasons, what is currently Afrinic as well. Some objects are created out of our region, but not many. If we look at coverage for the RIDB, it's kind of like the inverse of this, perhaps unsurprisingly. And like I said, there are many other more specific IRRs, but I don't want to go into them because of time today. But they cover mostly more specific regions. If we look at ROAs, then we see that there's been quite a good uptake in Latin America. LACNIC does not operate their own IRR, so but it does operate RPKI, so that is one of the reasons. But also in the RIPE region, there is considerable uptake. The light green colors here in Europe for the RIPE region are like 25%-ish in terms of prefixes, but if we look at the absolute space covered, then the numbers are a bit higher, basically indicating that it's the the bigger resource holders who are adopting this first in the RIPE region. In the APNIC region, we also see uptake. But obviously the uptake is much lower than the IRs at this point in time. Now, if we look at accuracy, I should explain what I mean by that. Let me get another picture. So accuracy is, we have an announcement, we have authorizations for this prefix, and does that actually reflect the announcement that we see or not, right? So it's a relative measure. So if something is not covered at all, then we can't really say anything about accuracy. If it is covered, then we can say, okay, how many of these things are configured correctly and how many things are configured incorrectly, let's say. Then for the RIPE database IRR, we see that the numbers look pretty good for the RIPE region itself, but outside of region objects are pretty bad. If we look at the REDB, then, well, the RIPE region is pretty bad. That's also very low coverage. But I think even other regions like Latin America are below par, and Africa is also not great. If we look at ROAs, then on the whole, I think the quality here is pretty good and actually better than what we see in the IRR. There are a few red dots here. It's mainly in places with very low coverage. So putting that all beside each other, so coverage, accuracy, well, this is a recap of what I just said. So in the interest of time, I won't read it out all again, but yeah, I just went through this. My conclusion, my personal conclusion would be that I would really consider using ROAs because they have provide quite good data in addition to the data that we have in IRR. But I wouldn't use them on their own because then you miss too much, of course. So this part, because I'm trying to cover different things here in this presentation. So so far I've been talking about, okay, BGP and what you might want to authorize and how you can use it in validation in your routing decisions. But there's also the setup side to this. So this is a bit specific to the RIPE region, but I guess that would expect that a lot of people in the audience are from this region. So how to set up a root object? Well, we can talk for much longer on this, and we have trainings that go into this in more detail. But yeah, essentially the holder of a prefix can create a root object. The holder of ASN to date still needs to improve, but that will disappear soon. We have a web interface that you can use. You can also use text-based updates or send updates via email or anything like that. Like I mentioned, so for historic reasons, the RIPE database allows the creation of out-of-region root objects. But there's been recent discussion on this. And the conclusion basically is that we will no longer allow the creation of new objects. The authorization by the ASN is no longer needed. So currently in the database, there's also out-of-region ordinum objects that were needed to authorize these objects. We will also not allow creating those anymore. The existing out-of-region objects will get a different source attribute, or a value for that source attribute, RIPE non-auth, so you can filter on them. But the intent, if I read the working group, but they have the ultimate say in this, of course, but if I read them correctly, is that the intent is that they will be removed at some to be determined date in the future altogether. Now, if we look at ROAs, something to keep in mind here is the maximum length attribute. I mentioned it briefly earlier. So with a ROA, you can say a specific ASN is allowed to announce a specific prefix. You can enable use a max length field there, and for example, for a /19, say you can see any up to a 24 from this ASN. You can use that if you habitually, do those announcements, but you should be careful because it does open you up to hijacks by other ASNs who spoof your ASN and announce a more specific prefix for you. So it's something to keep in mind. On the practical side, the RIPE NCC provides a easy-to-use user interface to do this. It presents, well, I'll just go into details here. This is the interface as seen by the RIPE NCC operational LAR. So this is our ASN that you see here mostly with our prefixes. Everything is good here. You see one announcement here that's marked as invalid ASN and muted. That's actually a beacon announcement that we use for measurements. So it's intentionally invalid. But for the sake of this presentation, I went and go through the motion of creating a ROA for it. You can just click on the magic wand button. You get a suggestion for to create a ROA specifically for this announcement, but you can also enter manual and enter details manually if you figure you want to do something different. Once you've done that, you go through to the next page, and basically your stage ROAs, as I call it, will be listed, and the effect on BGP, as we've seen it, will be shown to you, and you can decide to publish or not. So there is a question.
Yes, there is a question from APM, and the question is, does it exist an implementation step-by-step guide to set up ROAs?
So we have done webinars on, if you talk about the ROAs in the LAR portal, so for the service that RIPE NCC provides, we have done webinars in much more detail in the past, and there's a recording online. So we can dig up the link for that and share that. It goes into much more detail than this. We also have a lot of resources on our website on this. So yeah, I think that's all I can say about it here right now. Yeah. Another question?
There's another question, and the question is from Lines, and it is why we sometimes get a ROA warning email about the /32 that we blacklisted.
Okay, so that goes into, let me switch to the next slide, because another thing you can do here is you can subscribe to alerts. So we will look at the routing table that we see in the RIS route collectors and compare it to your authorizations. And if we see an announcement for something that is either not covered or invalid, you can get an email for it. Because, well, a bit of history behind this is that initially people were just not configuring things correctly. And by and large, most announcements are correct, fortunately, but some are not, right? So if you see something that isn't valid, then you should ask yourself, do I want to authorize this or not? You can, of course, choose to not authorize things. It will keep popping up unless you mute it. So there is this bell icon. Yeah, I don't think I can use my mouse here, but if you look at the line here that has the invalid ASN and the thing muted, that's the result from the bell icon that's on that line. So you can choose to no longer get alerts for this specific announcement. But if you see other ones coming up that you didn't explicitly mute, then yeah, you would get alerts about those. If that's indeed the alerts that you're talking about. I think our route collectors are all over the world, so they may see things that are filtered further up, so including 32s and possibly even. But typically, I think we wouldn't even see them here, so I'm not sure that this is really the question that you were asking. But yeah.
Tim, there is one more presentation, one more question here. It's from Mike Simpkins, and it is, if using an external DDoS provider, how would you set up the ROA so that the AS advertises 19 up to /23, but during the DDoS, AS X to ASY internet advertisers /24. I assume the ROA needs to be /19 with a max length of /24.
So I think the problem here is propagation, because yes, you could set up a ROA like that, and then you're prepared to use this service. The downside of it is that people can spoof your ASN. If you were to do it only at the moment that you do the anti-DDoS mitigation, then the problem is, yes, you can set up a new ROA, but will it propagate in time to make it to people who are validating? I think that's an area where we want to do more work in the future. I think there are ways to improve this further, but a lot of it depends on how people use it in their config. Like, do they use RPKI to route a protocol? Then the chance is likely that they'll get it quickly. But if they have other ways, like static config, then yeah, it could take way too long. So I had 2 more slides, but I can also skip them, I think. Basically, well, it's really short. What I wanted to say, future plans. I've shown the interface for ROAS, but we do plan to make this available for root objects as well. So essentially, provide one common interface to maintain both. This is actually, by the way, this is something that APNIC is already doing. One thing I didn't name yet is that you may also find that you've made authorizations and you forgot to remove them when they're no longer necessary. We want to make that more clear. And I don't want to go into more details, but I want to pitch it here. We do have a new version of our RPKI validator about to be released, and I would say watch the routing working group. We'll set an announcement there soon about this one. And yeah, the questions we already had, unless there are more. Otherwise, I would say thank you all and hand over to the next speaker.
Yes, and I'm back. While we are getting ready for the next presenter, that was a very insightful presentation from Tim. And if you have any questions later on for Tim, you can just send an email to the address tim@ripe.net. Next up, we have the presentation from Andrei Robachevsky, and he is the Senior Technical Program Manager at ISOC. And ISOC means Internet Society. We are very lucky to have him in the office here today. He travels quite a lot. He joined the Internet Society in March 2011. Actually, before that, he was one of our colleagues here at RIPE NCC. And his primary interest area is security and resilience of the internet infrastructure. So a lot of his work goes about routing security and how we can improve that. So he works together with operators, with research and policy communities. And today he will discuss a topic that is called manners. And if Andrei is ready, then I'm going to give the word. You ready? Yeah. Okay, then I'm going away and there's...
Hi, everyone. Thank you, Natalie, for this great introduction. Yes, a couple of last years I was busy with a community initiative called Manners. But in my presentation, I would like to talk more about the state of the routing system, and also how simple measures outlined in mutually agreed norms for routing security, which is Manners, can help us all improve and do better. So if we look at the routing system, and here I pulled some data for 3 months from a service called BGP Stream, which collects changes in the routing system and assess if there are suspicious events like hijacks and route leaks. So you can see there is no single day without an incident, and not just a single incident, but dozens of incidents that happen. So it's really a problem. Insecure routing, it actually basis for many other malicious vulnerabilities and malicious threats. It's a basis to mount a man-in-middle attack. It's a basis to create very easily denial of service attacks. And some of the attacks that can happen in some of the pockets, remote pockets of the internet, that can take anywhere from hours to days or even months to recognize and mitigate. And I mean, there are many cases, and I'm sure this session you already heard about several examples of incidents that happened that can take entire countries or regions offline for a significant period of time. So I don't want to talk about that because there were great presentations on how BGP works and how vulnerability happens. And the main problem is that, yes, BGP is based on trust, right? There is no built-in, when I say built-in the protocol way to authenticate information that you get from your peers. So either you have to believe them, which let's say 80% do, or you have to validate this using out-of-band data, other sources. There are two problems. One problem is that this trust is transitive. So I believe my peer believes me. And if a mistake happens, it spans continents. It propagates almost globally and sometimes really globally. And another problem is that if you want to validate and you want to look at data that we already discussed, like RPKI or IRR, there's a certain lack of reliable resource data when it comes to quality and completeness. So yeah, which leads to those are headlines. They're probably aware of different things that happen on the routing system, cause DDoS, havoc, and was picked up by media. So what's happening? I mean, let me distill this to three main things, and three main things. There are many other things happening in the internet, of course, but those are three main things that are in focus of this initiative called MANAS. And this is prefix route hijacking, route leaks, and IP address spoofing. I'll spend a couple of more time just discussing those things. So it's interesting that I think previous speakers, they covered those things, but probably it's useful to look at the same thing with different illustrations that can give you more insight on what's happening here. So route hijacking, basically when a network impersonates another network and says, hey, you can reach this destination through me. And in this particular example, ISX, an attacker announces the prefix that belongs to the customer, IS64501. And what it does, if ISB doesn't validate this announcement, accepts this, there will be hijack. So if ISB validates this and other peers validate it, or not validate but accept this, at least part of the traffic from ISA will flow to IS6. In many cases, I have to say, routing incidents are not malicious attacks, but they're configuration mistakes. Nevertheless, they cause significant damage, right? And not easy to fix because that requires cooperation from different autonomous systems. Another more subtle incident is route leak. And route leak is a policy violation, what is called in routing violation of valley-free routing. And this is the case when a prefix being re-announced violating this principle. Well, let me illustrate this with a simple example. If a customer, multi-home customer, accepts announcement from one of its transit providers and re-announces this same announcement to another transit provider, and that provider accepts this, that will be a leak. So without explicit filtering, accepting an announcement from the customer is a very common thing because that's a general policy when you prefer announcements from your customer. That's how you minimize cost, how you provide service to your customer. And in this case, if, for instance, ASB announces a prefix for Google Public DNS, right, which is quite normal, and the multi-home customer 64509 re-announces the same prefix to another network, they all of a sudden inject themselves in the path between other customers of this network and Google public DNS. So imagine if this is a configuration mistake, and if the prefix is not a very heavy volume destination, it will probably not be noticed. If it's a heavy destination, probably this customer will be under severe denial of service attack, just coping with this traffic. But imagine if this is an attack. This gives you an opportunity to inject any network, malicious network, in the path of almost any destination. That's sort of, I think, opens a great vulnerability in the routing system. Well, there's an example of how that happened, for instance, in case of Cogent and Atrato. You can look this up later. And the thing is, while hijacks are more noticeable, route leaks are much harder to detect because you really going into intent and you need to know the relationships between the different networks, whether it's customer-provider relationship or it's a peer-to-peer relationship. And finally, address spoofing, which is a root cause for so-called reflection amplification attacks. And in this case, it's not routing per se, but it's very much related to routing because it's based on the architectural sort of principle. Routing doesn't use source IP address. So in many cases, this check is not done. And therefore, you can impersonate yourself as coming from another source. And that works in reflection attacks when you send, for instance, your DNS request to as many open resolvers as you can, impersonating being a victim. So you substitute your own source IP address to the source IP address of this victim. And what does open resolver do? They will reply which much bigger answer to this IP address, collating all this traffic to this victim, causing enormous denial of service attack. This can also be fixed because there are things, techniques being developed and being around here for decades that can verify this at the level of, and in some cases it's also coupled with routing. So one of the things is that we talk about this in terms of anecdotal evidence, and the important question I think is to say, hey, and what's the scale of this problem, right? How big it is and how it develops. So I looked at some of the data here, again, pulled from BGP stream data. And this is some caveats here, so bear in mind. Now, globally, if we look at 2017, just 1 year, we had about 14,000 incidents, outages or attacks, which I illustrated. Over 10% of all networks experienced such incident. 3,000 of networks were a victim of at least one routing incident. And 1,500 networks caused at least one incident. So let's look at this in more detail. By the way, on this slide, you can see that outages are, well, I would say only 62%, and actually routing incidents cause 40% of all bad things that happen to networks. Outages by country. Well, Brazil here is leading the list. And you can see those are top 10 countries where outages happened. If you normalize this by the number of ISs announced in this country, I think the distribution is slightly different. So you can see Iran and you can see Nigeria as being at the top of the list. And this is true when you play with data, how you normalize this thing. So I think finding right metrics is important. Here if we look at potential victims, people that were involved in this incident and suffered from this, we can see a slightly different list. And on the right, you can see the top victims. Colombia, for instance, leads this list, followed by the United States. Not surprisingly, because United States, they have a lot of networks being announced and therefore being a potential victim. Looking at culprits, it's interesting, and you see the distribution is slightly different from the victims, meaning that some countries suffered more from others. you're isolating the list. But again, if you normalize this by the number of autonomous systems announced in the country, the distribution is slightly different. Now, that's how routing security looks from for a year, right? From the outside. But how are we doing? I mean, do we have tools? And if we look at the tools, yes, I think we have tools. We have techniques. We have IS and path filtering. We have RPKI, BGP-SEC as a protocol, even standardized. But we certainly lack deployment. If you see how quickly incidents propagate without any obstacles, you cannot say that deployment is big. And it's always, I'm coming back to this lack of reliable data. Now, security is a very difficult area, and security needs a systemic approach because security is not a state, it's a process, right? It's continuous improvement. And in a corporate sense, you have those frameworks and you have those processes enabled. But how do you do this in the internet, in this ecosystem with 60,000 independent networks making their own decision? So we need a systemic approach improving routing security. Another problem is that we all here together. So even if you deploy those tools, even if you do all the stuff that was spoken here at this at the seminar, you are not so much securing your own network. You're actually contributing to the security of the overall routing system. And put it another way, security of your own network is in the hands of other network operators. So it's very important to establish or facilitate this sort of reciprocity. When you develop something, you expect from others that they will deploy those tools and techniques as well. So let me introduce this initiative, which is industry-led, which is called Mutually Agreed Norms for Routing Security, MANAS, nice acronym. So MANAS tries to do exactly this thing. It tries to enable this common reference point, right, that you can use in systemic approach routing security. And it can create a community that facilitates the sense of reciprocity. It defines a norm, a new norm in routing security, routing hygiene by defining 4 actions. I'll just show you some of them. Well, not some of them, all of them, by the way. So it's filtering, anti-spoofing, coordination, global validation. And some of you, if you just look at the titles, you would say, hey, motherhood, apple pie, we've known this for ages. We've done that. Nothing happened. Now, MANAS tries to do this in a different way. It actually provides, it's not a best current practice. It's a minimum norm that we ask operators to implement. Those actions are very much limited in scope to be optimized for low risk and low cost. For instance, if you look at filtering, it's not just global filtering. You're filtering your customer cone. You're cleaning your part of the street. The same applies for anti-spoofing. Now, when you look at global validation, we're not talking that you need to validate all announcements globally. It's just you need to populate those repositories that Tim just talked about, IRR and RPKI, so third parties can validate your announcements. So what are the benefits of implementing MANAS actions? I think one way is that it signals organization security forward posture. It's when you read best practices, one important question that you ask, how many people around have implemented those things? I think in the internet, we miss this signal to say, yes, we know sort of by word of mouth that this network is performing well and this network is usually a cause of trouble, but there is no sort of one recognized signal that can assess your peers or your customers. Of course, the more networks join, the more incidents we mitigate or prevent, right? It also, implementing those actions improves your operation efficiency, because if you install those processes, if you deploy those tools, I think in general, your troubleshooting can improve. So it looks like a win-win. Joining MANAS, you join this community, right? You grow this community, making effect of reciprocity much higher. So it actually improves your return on investment when you deploy those measures. And the more network operators apply manners, the fewer incidents there are. I have to stress, manners, as I said, not the best current practice. It's a stepping stone. It's a stepping stone to better routing security. It's a minimum that operators should implement. This is a new norm, right? So it's not the best current practice, so there is no confusion. So why join manners? Well, there are three things that I would like to suggest. One of them is to improve your own security posture, to join a community of security-minded networks, and it's a trusted community that can bring up and discuss other issues and that make mitigation of routing incidents also easier. And use manners to signal your security posture, as it's, for instance, as a competitive differentiator. Well, this is some URLs if you want to join. This is the manners.org site where I invite you to look at this and check and get involved in the community. So just 2 minutes. I know my time is short. A few minutes to spend on manners related stuff. So, well, I kind of said, 4 actions, simple actions anyone can implement, but I think they're not super complex, but they still need resources, and it's still not a very lightweight lifting for many networks. Security is hard. So one thing that we went off and did with the community, we created an implementation guide. And when we created this guide, we thought, oh, let's just create a 1-page checklist that you say, tick, 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 I implement all the actions. Resulted in 50-page document. Because yes, routing security is difficult. Because yes, you need to understand how routing registries work. You need to understand how RPKI works in order to, create all this infrastructure that will enable the tooling that you need to deploy to make your network routing secure. So this is the implementation guide. Please go ahead and read it. And if you have comments, would love to hear from you. Another thing that we also did, we created online tutorials. We created 6 training modules based on this implementation guide that you can, at your own pace, go and check. Each module has a quiz, so you can check your level of understanding of the problem and your level of your sort of how comfortable you are in implementing those things. Oops. What's next? We are expanding. We're also bringing other categories of participants on board. Next is IXPs, Internet Exchange Points, very important partners in this game, because IXPs, they have local operational communities with common objective, and there is no such thing as global community, right? So we need to work with local communities. So taking IXPs as ambassadors is extremely important here, and we hope we'll open this program very, very soon. And with this, I'm finishing up. Please go to this website to learn more. Thank you very much. I'm happy to take questions.
There's a question, Andrei, and it's from one of our active RIPE community members, Alexander Isavnin, and he writes, is manners effective? How its effectiveness is being measured over more than 5 years of its existence, or can it be measured? How can one control the fairness of manners? That's a lot of questions, Alexander. Let's start with the first one. Is manners effective, and how can its effectiveness being measured over more than the 5 years of its existence? Andrei.
Right. Well, good question. Manners is not 5 years old. It's almost 3 years old. But that's still a very good question. So what we are doing this year, we're actually starting a project. Well, we started this project on measuring, first of all, measuring manners readiness and creating what we call manners observatory. So I showed you some of the data about routing, and I think we all missing this, the statistic, the facts about routing, how routing system is doing over time, right? Are we getting better? Are we getting worse? Are some networks getting better? Are some networks getting worse? So we are working on this, what we call manners observatory, where you can trace and probably infer if some of those measures introduced by manners are leading to improvements. We're also working on what I call menace readiness. We came up with 16 metrics that you can measure passively by observing the routing system, by observing the data registered in routing registries and RPKI, to sort of create a metrics of how what is the level of compliance of a particular network with regards to menace actions. So yes, good questions. We are working on this, and I think by the end of this year we'll be able to show something. I actually hope to show something already at the RIPE meeting in May.
And Andrei, the second part of Alexander's question was, how can we control fairness of manners participants following a BCAP? What if any leaks, hijacks, or spoofs are happening by manner participants?
Yes, well, I think I answered this question partly because what I referred to menace readiness. So we hope, we want to produce those reports and actually at some point to make this publicly available so people can see for each menace member if they experience some of those incidents or configuration mistakes and how they mitigated those things. So there will be sort of, red, amber, green tick box assigned next to a menace member. Yeah. Well, thank you very much, everyone. I hope you enjoyed that.
Okay, thanks a lot, Andrei. And as one of the participants is mentioning, I think there's much work to do, but now is the time to start the work, and I could not agree more. So thank you all very much for that. I see a lot of thank yous. We are going into the lunch break here. And some of you have issues with Adobe Connect with the platform, that they are kicked out and not cannot be logged in back again. We are aware of that. We're working on a solution with Adobe, and we expect to have that resolved after the lunch break. So bear with us for a little bit. We will be back in about 20 minutes with the next session. And so don't go too far. It's only a 20-minute break, and then we will have the use cases section. So hopefully see you then.